9.2, find the median and mean and make inferences from a double stem and leaf plot. So here it's got a stem, and then 17, 18, 19, 20. And then it's got 7, 5, 8, 9, 8, 7, 1. Alright, so for here it says the stem and leaf plot shows the weights in pounds of 2 football teams. How are we supposed to read this as opposed to a regular stem and leaf plot? Gentlemen, you can go back to your desks. How are we supposed to read this? So it says weight in pounds. What's this number mean?
Ones.
What?
Ones place. Right?
The ones place, yeah, and this means the
Tens place.
tens and
Hundreds.
hundreds. So this number right here represents how many pounds?
7.
Nope.
17.
Not times 17.
Oh, 100. No, 1,000. I don't know.
No one said it. What? Yeah, 177. This number is
181.
181.
186. 88.
Someone else?
191.
Oh.
93, 195.
So on and so forth. What about this one?
Oh.
100.
What? One what?
88.
Yeah, 188.
199.
Yeah, so on and so forth, right? You get the point. But basically, a double stem and leaf plot is going to have, you've got, hey, one set of leaves over here, one over here, and you read it the exact same way. Why are these numbers here, like here it goes like 7, 1, 6, 8, like ascending order, and here it's in descending order? Why would it be why would it be going down on this side? Just because left side's not as cool as the right side, so it's got to do things opposite.
Exactly.
What? It's what?
Maybe because it's like a number line.
Yep, it's kind of like a number line, and also the stem is like the center, and so you're always going to have, you're reading from the center out. So 17, 181, 186, 188, 181, 187, 188, 189, so on and so forth. So what they're looking for is the mean, median, and to make inferences. So I'm going to start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means I know my halfway point is going to be where?
5.5.
5.5, or the sixth number. Remember, you always divide by, you always round up. 5.5, go to the sixth number. 1, 2, 3, 4, 5, 6. So the median here is 193. And here, I gotta be careful. 1, 2, 3, 4, 5, 6. I don't just go left to right like I did before. I gotta go right to left if it's on the left side here. 1, 2, 3, 4, 5, 6. So 189 is the median over here. 193 over here. So that means I know these ones are gonna be a little bit higher because they're median. Mean, I use my calculator to add up 177, 181, 186, 188, so on and so forth. Divide by how many you have. You guys know how to find average. I'm not going to spend more time going over it. So median means this becomes, we'll go median, mean. So the median here is 193. Median here, 189. The mean, let's see, your book did it for you. Mean weight of team A is 188.7. And mean weight of team B is 194.1. What does that tell you? So here the mean is much higher than the median, and here the median is much higher than the mean. Look at where the numbers are. What does that tell you? Got the right numbers there? Team A, oh no, I did mess up the numbers. This one's supposed to be over here, so this is 194.1. And this is 188.7. How is this data distributed? Is it like relatively even on both sides? Is it like, hey, you got big numbers, outliers that are pulling it way up, way down? Yeah?
Left side's bigger.
Yeah. Left side's bigger at 189, right side's bigger. 193, 194, and look, we've got more numbers that are heavier down here, so it would make sense that the right side's gonna be bigger there.
That's true.
This is a kind of a normal distribution of data, where you kind of see like, hey, in the middle it gets a little bit heavier, it's a little bit less on each. This one gets a little bit heavier on the higher side numbers, that's why you're gonna see the median and the mean go up more. But basically what that means is you kind of confer like, hey, this team is going to be bigger, and we also know especially the bigger guys on this team are much bigger. So D said, on average, which team has heavier players? Well, it's Team B, right? Because we got a bunch down there, which you probably could have told before, but finding the mean and the median gives you a better idea. Guided practice number 3 asks you to do the exact same thing. We're going to skip that. Example 8 on 198. 7-leaf plot shows length in centimeters of some salmon caught on a fishing trip. And so it says 1, find the median length of the salmon, which they find 23.5. So then that says find the mean. So median 23.5. Now without even looking at B, from what you see on the bottom of page 198, the median is right in the middle of those numbers in the 20s. Where is the mean going to be, higher or lower? Where is the mean going to be, the average? Is the average going to be higher than 23.5 or lower?
Higher.
Why is it higher?
Because the highest number, or it gets like super strong at the end.
Yeah, the higher numbers at the end are dragging it on up. So what is a more useful number if you're like thinking about like, hey, on average, what's the average fish look like here? Is what's going to be more helpful, median
Range.
or mean?
Or median.
Yeah, median, because median tells you what about the average fish is going to like. Mean, if you could take all the meat from all the fishes, and you're trying to see how big they are, mean will tell you about how much you get on average, but it's not going to actually give you a good idea on what most of the fish look like. So median, again, like we've talked about before, median is the better number to use. So it says compare median, median. What can you infer? That those high numbers dragged up the mean, basically. What's the range of the data? They ask you that. That's pretty easy. Got to practice 4 asking the same thing, but we're gonna skip it, and you guys can start on your assignment. Guess what? How many problems you got? Only 3.